Okay, we are going to graph the quadrilateral ABCD, and we're given the coordinates for those points. And then there's a part A and a part B, and actually there's a C and there's a D too. So let's begin with the graphing of the coordinates. So I'm going to go -2, 6. So draw in -2, +6, -2, +6. This is point A at -2, 6. And it actually helps to see those numbers sometimes. So I'm writing there because I know from experience that could be useful. The next point, B, is at 2, 3. So I'm going to go over 2 and up 3. Here we go. This is point B at 2, 3. The next point that I have is C, which is at 2, -2. So I'm going to go 2, 2 and then -2. All right, there you go. C is at 2, -2, right? And then the last point after that is D, which is at -2, +1. So D is going to be -2, +1. Okay, here we go. D is at -2, +1. Woo! Okay. That's the shape we've got there. So I guess ruler time, right? Let's ruler time. So we plotted the points. Now I'm going to grab a ruler and okay. I'm going to connect these two dots here to draw segment B. What is that? B? I don't know, BC. There we go. I'm going to do the same thing on the other side and connect the dots for AD. Beautiful. Rotate this thing up. Okay, this is interesting. This is interesting. So this is, and then notice I'm not even changing that angle. I'm still leaving it at 37 degrees. I highly suspect this is at least a quadrilateral, right? It's at least a quadrilateral. So then part A says a rhombus is a quadrilateral with 4 congruent sides. Verify that ABCD is a rhombus. Oh, are these sides congruent? I have a trick for this. I don't actually need to find the length of the side. All I do is I just kind of consider these bounding triangles. So this one and this one. Oh, I am going to actually need, let's see, and then this one down here and this one right here. So this side that I'm going to highlight in green, right, how big is that? Well, it's got, this triangle has a height of 3, and this is 4. It's a 3, 4, 5. 3 squared is 9. Right? 4 squared is 16. When I add 9 and 16, I get 25, and the square root of that is 5. So that's just the Pythagorean theorem. It's a right triangle. This is 5 units long. This is also over here. This is also a 3 and a 4, so that means that this other side across from here that I'll also highlight in green must also be the number 5. And then finally, if I look at just the change in the y values, you can see I'm going from 1 to 6. Well, if you go from 1 to 6, that's a change of 5 also. And over here, I'm going from -2 to +3, which is also a change in 5. So absolutely, this is a rhombus. All 4 sides are 5 units long. Okay, so I verified that. What is the area and perimeter? Okay, perimeter is easy because it's all 5 units. So perimeter is 5 times 4. There's 4 sides and they're all 5 units long, so it's 20 units. 20 linear units is the perimeter. Area? Well, the area of any parallelogram is just base times height. Now there's something funky, right? The height literally needs to be the distance between the two things I'm going to choose to call bases. So if I look at this and I say, hey, this thing I'm going to highlight in pink, that's a base. That's 5 units long, and this is a base. If those are my bases, then this segment right in here that I'm highlighting in red, that would be the height. So literally, if I just multiply that red segment times the pink one, I'm going to get the area of that parallelogram. And I'll show you, I'll do it 2 different ways. So let's go ahead and do that. This is 4, the red unit it's 4 units long, And the one that's pink is 5. Oh, that's interesting. I've got that the area is 20 also, but this time they're square units, right? There's 20 of these little squares inside of here. Another way I can do that problem. You can see this bigger rectangle that I made, this bigger rectangle. Well, the bigger rectangle is 4 by, what is it? 1, 2, 3, 4, 5, 6, 7, 8. It's 4 by 8. 4 times 8 is 32. So that whole rectangle, the rhombus plus the 2 triangles is 32. Each one of these triangles, I can see they've got a base of 3 and a height of 4. So these triangles all have an area of 1/2 3 times 4. I'm not writing that well. 1/2 times 3 times 4. My pen just got weird. 1/2 times 3 times 4, which is 6. So there's 2 of them, right? This has an area of 6, and this one has an area of 6. Together that's 12. 32 minus 12 is 20. So that's definitely the area. The area is 20. Area is 20 units squared. What is the slope of the diagonals AC and BD? Okay, so the diagonals, right, are the ones that go, they said AC and BD. So the diagonals of this thing, and this diagram's getting a little crowded, to be honest. If I'm honest, this diagram's getting crowded. These are the diagonals. I'll highlight them in white. This is a diagonal right there. And this is a diagonal right here. Okay, those are the diagonals. Ooh, pretty. Let me erase some of the things that are not part of the diagonal. Okay, so those are my diagonals. And it says, what are the slopes of the diagonals? So if I look, I'm going down 1, 2, 3, 4, 5, 6, 7, 8, over 1, 2, 3, 4. Oh, okay, so this was down 8 over 4. So this is 8 over 4. This has a this one has a slope. This one has a slope of -2, right? This one's slope is -2. This one is up 2, and then over 1, 2, 3, 4. Well, guess what? That has a slope of 1/2. Those two things, right? Those slopes, 1/2 and -1/2, because they are opposites and reciprocals, because when I multiply them, I get the number 1. I know that these diagonals form a right angle. Let me write that down. So it says, what is the slope? Okay, so the slopes are, what was one of them? One of them was -2, and the other one was +1/2. So the slopes, the one with the C, so AC had a slope of, boy, read it, Roberts. Okay, -2, and the other one had a slope of +1/2. Okay, since the slopes are opposite in sign, one's positive and one's negative, and reciprocals, the diagonals are perpendicular, right? We got right angles right there. Those diagonals are meeting at a right angle in a rhombus. I don't know if it does it for all rhombuses, but it definitely does it for this one. And then finally, what is the point of intersection of the diagonals? What is the relationship between this point and diagonal AC? Okay. Well, you know, when I look at it, the location of that point is at 0, 2, right? 0, 2 is that location. And if I look at 0, 2, oh my gosh, this is busy. Oh, if I look at 0, 2 and I focus on point C down here and point A up here, I'm only making it worse. Well, if I add the x's, -2 plus 2, and then that's 0, half of that is still 0. So I can see that the x value for the midpoint is 0, and 6 plus -2 is 4, half of that's 2. Guess what? Those diagonals, I'm just saying it for one of them because that's what they asked, but that diagonal is bisecting the other one, right? They're bisecting each other. They're meeting at the midpoints. So I'll just go and write this down. What is the relationship between this point and the diagonal? Well, the midpoint, what is the point of intersection of the diagonal? Okay. They meet at 0, 2, ... 0, 2 is the midpoint of segment AC. Beautiful. That's wonderful.